Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassador series. Here we are going to continue with our calculations on empirical formula and molecular formula. This is the question 3 that we are going to do and question 4. Here is the first one is a hydrocarbon gave the following results. Now carbon is 88.89, hydrogen is 11.11%. Deduce its empirical formula. So very simple, as we've been doing always. What do we do? Solution. Here we are going to write the solution here and write it nicely. So here solution, chemistry, regarded by the way we present answers nicely, and then we write the various percentages. So percentage of carbon is what? 88.9%, and here hydrogen is what? Percentage of hydrogen is what? From the question is 11.11%. 11.11%. So 11.11% as percentage of hydrogen is 11.11%. Now once you do that, you check whether the sum of the percentages are up to 100. It is always advisable, so that if there's a huge difference, you know that it is for something else, and then you do the subtraction. So percentage, you make sure that you add them. Okay, this one there, I'll urge you to always cross check whether when you add them you will get that. So 88.98 plus what? 11.11. Now when you do that, when you add 11 here, you are going to get 100 exactly. Okay, so once you know that, then you know that there are only two elements within the compound, and so your calculations become much more easier and faster. Okay, calculations become much more easier and faster. So then you progress. Good. So the first one, you write how many different elements are there in the question. We have carbon. Good. We have carbon, and then we have what? Hydrogen. We have carbon and hydrogen, and then I told you that when it happens like that, you write the percentage under directly, and here we are going to get 88.9%, and then you are going to get 11.11%. So these are all in percentages. Okay, and then you find the mole. How do you get the mole? You divide. Mole is the same as what? Mass over what? Molar mass. Is the same as mass over molar mass. Okay, now this percentage is in terms of mass, so this, we take this one as the mass. So we divide by the molar masses of each of the atom, or the relative molecular mass, or the relative atomic mass for each of the atoms. And here carbon is what? Carbon is 12. You always know carbon is 12, and they'll give it to you in the question, so don't worry your head about that. So carbon is 12. Okay, so you divide this one by 12, and here one hydrogen is what? Is 1. That's the relative atomic mass for hydrogen is 1. Once you do that, you get the mole. Okay, so the first ratio becomes 7.41, and the other one become 11.11. Now you've gotten the mole, you now go on to find for the relative mole. Okay, the relative what mole. Find for the relative mole. Find for the relative mole, or you simply divide the mole by the smallest ratio over here. So here between 11 and 0.11 and 7.41, the smallest one is what? 7.441. So you divide this one by the smallest. Okay, find this one by the smallest. You divide this one, you divide everything by the smallest. Divide throughout by the smallest first ratio. Okay, divide it by the smallest first ratio, so you get it. When you do that, here you are going to get 1, and when you divide it very correctly, the other one, you are going to get 1.49. Okay, 1.4 now you can see from here that here you've gotten what we call the smallest ratio. Okay, you've gotten the smallest ratio. You got what we call the simplified ratio. The simplified ratio. So what we've gotten here is a simplified ratio. Now once you get a simplified ratio, I told you in other lectures that we have to round it. Now, but okay, when you are rounding, you should be very careful. Okay. Now this one you cannot just round it like this, because this one is it is slightly below 5. It is slightly below 5, and we always want a positive. We always want a whole number. So you run in such a way that you get a whole number. Okay, you get a whole number, and I'll give you the guidelines. Okay, for that. Okay, normally you take a precaution that if you are rounding, you take a caution that if the decimal here is the decimal of 1.49. okay, the decimal is what? 0.49. okay, the whole number is 1. okay, the whole number is 1. So 1 plus 0.49 is what? Is the same as what? 1.49. So we have to look at the decimal before we round. Okay, when you look at the decimal side, it's 0.49. when add it to 1, that before you got this one. Now normally it is within a range, so you have to be advised. So we have, if it is from 0, if the decimal is from 0.025, if it is between that, we do something. And if it is exactly 0.52, we do something. If this one it is 0.7, if it's 0.75, okay, we do something. Now if it is exactly 1, to do something. So this is how to run the decimal. Now if it is exactly, okay, if it is between this number, okay, if the decimal is between this number, you throw it away. Okay, just throw it away. Okay, just forget it. Okay, just throw it away and use just the whole number. Okay, so just forget it and use the whole number. Just stick to the whole number. Okay, just stick to the whole number. So assuming that after rounding we get something like 0.02 or 0.20, okay, like 1.20, you got 1.20, because the decimal aspect, okay, is is less than 0.25, you throw it away, you use just the 1. So the empirical formula will just be 1. Have you got what I'm trying to say? So that is it. So if the decimal aspect is less than it's less than this, if it is between 0 and less than 0.25, okay, you throw it away. Okay, you just throw it away. Okay, and then if it is exactly 0.25 to 0. that one, okay, you multiply it times a number. Okay, you multiply it times a number. It's very important. Multiply it times a number. Okay, here the number you multiply, here you multiply it times what? Times 3. You multiply the whole thing by 3. In that case, you multiply everything, all the decimals that you get by 3, all the decimals by 3, you multiply all the what? All the simplified ratio by 3. So basically that is it. And if it is this one, so here if it is that, you multiply. In that case, if you have say if it is say, let's say 0.025, let's say it is 4.35. Okay, let's say it is 4.35. okay, if it is 4.35, you see the 35 is bigger than 25, so you multiply these numbers by 3. Have you gotten that? Multiply times 3. So if it is that, multiply times 3. okay, if it's that, multiply times 3. Now if it is this, very close to 0.5, very close to 0.5, multiply times 2. If it is 2.5 or very close to 2.5, multiply it by that. So we multiply here by 2. Have you gotten that? So if it is exactly 0.5 or very very close, that is 0.5 or say 0.49. okay, so these ones are almost the same. okay, they are almost the same. So if it is like 49, very very close, you multiply it times 2. Have you gotten that? Now if it is beyond, okay, if it is beyond the 0.5, if it is beyond 0.5, you also multiply it times what? Times 3. So basically that is it. Yes, so multiply times 3. Now if it is between 0.75 and 1, and then you round it to 1, so you round it. In that case, you just round it to 1. In that case, if it is in our first instance, I remember we got something like 5.9 something, and then we just round it, we got 6. Because the decimal was what? Bigger than 0.75, we just round it. So that was a trick that we used there. So basically, my friends, this is how to do that. If you are not careful, you will lose points. Please, if you are not careful, you lose points. When you are rounding the numbers, check the decimals. If it is between 0 and 1, check whether it's between 0 and 224. If it is between 0, that is between 0 that is less than 0.25, just throw it away. And then if it is above 0.25 and still between that to this one, just multiply times 3. If it is if it is 0.5 exactly or very close, like 0.95, then multiply times 2. And then if it is that and that, multiply times 3. So here we are going to use that same rule. So you can see that here it falls what? Here it falls here. It's very close. It falls here. Okay, it falls here, very very close to this. It falls here, like it falls here. So you just multiply here times 2. So in that case, you multiply everything times 2. Okay, you not just multiply 1, multiply everything times what? Times 2. Okay, so here become 2, and here when you multiply here, you are going to get 2 point. You are going to get 2 point. So you are going to get 2.98. You are going to get 2.98. When you multiply everything times 2, you get what? 2.98. And then from here you can do your simple thing. So here you can see here is exactly 2. Okay, so here carbon become exactly 2, and then here becomes what? Becomes 3, because the 2 and the 2 is, the 9 is very close to 2, so you can just round it and then you get 3. So this one is very close to 3, so you can just round it. So the empirical formula for the compound, okay, the empirical formula for the compound becomes, okay, the empirical formula for the compound becomes this. Okay, so the empirical formula, okay, for the compound become C what? 2 hydrogen what? C2 hydrogen what? 3. C2 hydrogen 3. That's the empirical formula for the compound. So this is what they are asking for. All you need to know is to just follow the rule, write the percentages, and then add the percentage whether they are equal to 100. If they are equal to 100, write all the elements, write the various percentages, divide by their relative atomic masses to find the mole, further divide the mole again, or find the relative mole, and then get the simplified ratio. Okay, get a simplified ratio, and then use the rules to check, okay, to know which numbers you need to multiply. And then once you do that, you then get the integer out, and then you just write this one. So basically that is what it is. Very very simple for you to know. Very 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 simple. Okay, very very simple. Let's go to the second question. Okay, let's go to the second question. Okay, so let's go to the second question. The second question says that an organic compound A contains 48.6% of carbons and 8.1% hydrogen, the remainder being oxygen. The vapor density of A is what? 37. So first determine the empirical formula of the compound and determine the molecular formula of the compound. Very simple question. These are very simple questions. So we are going to use this column to do that question. So just follow me there. Okay. So the first one, so that is solution for the second question. So solution for the second question, that is solution. They underline it very nicely. And then you write the percentages. So here we are going to get percentage of what? Percentage of carbon is equal to what? 40 what? 8. Sorry, the percentage of carbon is 48. So it's 48. It's 48.6%. And then the next one of hydrogen, percentage of hydrogen, okay, is 8.1%. Okay, that is point, please. So 8.1%. Good. And when you finish, you add the percentages. You add the percentages to make sure that everything is up to what? 100. If it's not up to 100, then you have to know that there is a remainder. Maybe you are lucky the question will give it to you that there is a remainder. So add them up to what? 100. So here you are going to get. It's not going to give you 100, right? So it means that there is something over here that we don't know. There is something over here. Let me just put that. There is a number here that is missing, that is not there. And how do you find the number? It is that equal to, it is 100 minus what? These two things put together. So your calculator can just give you the answer within a minute. So plus 8.1, and when you do that, you are going to get, let me change the color. So we are going to get 43, okay, 0.3%. Now the question says that the remainder is oxygen, so automatically the percentage for oxygen become, okay, the percentage for oxygen become 43.3%. okay, percentage for oxygen become 43.3%. Now once you do that, then you now go and to find the empirical formula. That is what we said earlier. So first you write the different elements. So we have this, we have that, we have carbon, hydrogen, and then oxygen. That is what this contains. And then write the percentages, the respective percentages. Yeah, the percentage is what? The percentage is what? 40 what? 8 point this, and then this become oxygen. The percentage is 8.1, and then the other one become 43 point this. That's what we calculated for. Once you do that, then you find the mole. And this I've been saying always, that the percentages are masses. So you divide the mass by the molar mass. Divide the mass by the molar mass. The molar mass for carbon is 12. And this one by this, the molar mass of this is 1. And then O by what? By the molar mass is 16. When you do your mathematics, well, you get the ratios become, when you do your mathematics, well, the ratio become 4.05. okay, and here you get 8.1, which is the same thing, and the other one you get 2.71. okay, 2.71. So when you do that, and then after you divide the mole, okay, or otherwise find the relative what. So you further divide the mole. So further divide the mole against the smallest what ratio. So what is the smallest ratio here? 2.71. The ratio, the first one is this, second one is that, second one is that. When you do that, find, still divide. This time it means you are finding for the relative what? Mole. is the same as just saying divide the mole. So here you divide by the smallest mole, and the smallest mole is what? Is 2 point what? So 2.71, and you are going to get 8. Divide all throughout by the smallest, and divide this by itself because it's the smallest by itself, so you are going to get it. And then when you do that, you get the ratio, that is the simplified ratio. You get the simplified ratio, okay? The simplified you get the simplified what? Ratio, okay? You get the simplified ratio. So here the simplified ratio become 1.49, okay? The next one become 2.99, and the next one become what? The next one become 1, okay? The next one become 1. So when you do that, you get that. So quickly you do that. Now the next one is to now multiply, okay? Now multiply by the rule that I taught you earlier. You multiply this one, the decimal, check always the decimal, okay? So the decimal must be between 0 and 1, and if it is between 0.5, if it is less than 0.5, throw it away. If it is exactly 0.5, okay, then you multiply here times what? Times 2, and then times 3. Multiply here times 3. If it is here is what? Here is if it is 0.75, okay, and if it is that, you also multiply it times what? Times 3, okay, and then exactly this one or very close to this, you multiply here times 2. Have you gotten that? So that is it. So you multiply. So you can see that here it is the decimal is 0.49, okay? The decimal is 0.449. I'm talking about this. For the carbon, the ratio for the carbon is 1.49. Have you gotten that? Now how do you run it? This one you just don't run it anyhow. This is very close to what? This is very close to 1.5, okay? It's very close to 1.5, very close to 1.5, okay? So you assume it is 5, and then you multiply it times what? Times 2, okay? You multiply here times 2. So once you multiply here times 2, everything must be multiplied times 2. That's what I said. So everything must be multiplied times what? Times 2. So here when you multiply times 2, you are going to get 2.98. When you multiply here times 2, you are going to get what? You are going to get 6, and then you are going to get here 2. Okay, so here it is close to, it is exactly 3, you know, and here is what? 6, because you can just move the 9 to 1 because of this, that. So 9, as you said over here, okay? Because if it is 9, then you can just add 1 to the next one, okay? You can just add 1 to the next one. So then we are going to get this, and you are going to get this. So the simplified ratio, that is the empirical formula for the compound, therefore become the empirical formula for the compound, the answer. So the answer become the answer to the question, okay? Okay, becomes what? C what? C3 H what? 6, C3 H6, and then what? And O2. That is it. C3 H6O2. C3 H6O2. So that is the answer. Okay, let me show you the answer. Well, so the answer is what? C3. Okay, let me zoom in. Okay, so yeah, so it's the same. So the answer is what? The answer is what? Good. C3 H6O what? O2, because of this, because of what we have gotten here. Okay, remember we got because of here, where we have our this one to be what? Our carbon is this 3, because we run this one 3, and here is 6, and here is 6. So basically that is it. So this is the empirical formula determination. This is the empirical formula to the determination. Now, how do we determine the molecular formula? How do we determine molecular formula? Okay, so quickly. So how do you determine the molecular formula? Now, there is a mathematical relation that we do, okay? So you should know that there is a mathematical relation. You have all our figures now. Now let's use them. Now, we got our empirical formula to be for C what? C, it was C3 O this and O2. That's what we got. Now there is a relation. There's a relation between empirical formula, okay? There's a relation between empirical formula, okay, and molecular formula, okay? Molecular formula, okay? And so this relation is this. Now the empirical formula, okay, empirical formula now is connected to the molecular formula by a common factor of n. Now several empirical formula will give us molecular formula. Remember we said that molecular formula shows us the actual whole number ratio, okay? Shows us the actual whole number ratio of the atoms of the elements within the compound. So basically what it means is that several empirical formulas, put together will give you this, okay? Several empirical formula put together will give you this. Now this has its mass. Every empirical formula has its own mass. So here we have this formula. You can find the mass of the empirical formula, and that mass become the empirical mass, okay, unit. Become the empirical mass unit. Empirical mass what? Empirical mass what? Unit, okay? Become the empirical mass unit, okay? Now also times a certain factor will give you the molecular mass. So the molecular mass is gotten from the molecular formula, okay, by adding all the masses of the atoms that are there. So formula. So this is the relation. So the simplest mass of a formula that we can get is the empirical mass, and the actual mass that we can get is the word molecular mass. This is because empirical formula just shows us the very smallest ratio of atoms, smallest number of ratio of atoms within the compound, and here it shows us the exact. And so this gives you empirical mass. So when you get the smallest unit, okay, you can multiply it times a common factor, that factor, and then you can equate it to that. So in the question, they gave us what we call the vapor density. Now vapor density is related to molecular mass, so you should know that vapor density, that is vapor density, okay? Vapor what? Density. Vapor density, okay, is related to molecular formula. It's related to molecular formula and molecular mass. Related to molecular what? Mass. What do I mean by that? Now, when you multiply 2 times vapor density, the vapor density, now I'll explain this one in our next video because of time, okay? Because of time. When you multiply the times 2, you get molecular what? You get molecular what? Formula, okay? And you get molecular mass. So it means that they have given you the molecular mass for the compound. It means the molecular mass for the compound is given. Multiply the vapor density times 2, you get that. So therefore, the molecular mass for the compound, that which shows that the total mass of the molecule is 2 times what? The vapor density 37. Okay, and that's when you multiply it very well, you are going to get 74. Okay, you are going to get 74. So once you do that, you will then connect the empirical mass, okay, unit or empirical formula to the molecular formula. So you connect it. So empirical, okay, the empirical formula by the factor to the molecular what? To the molecular formula, okay, to the molecular formula. And here the empirical mass, the compound we got was what? Was 3 carbon, 6 what? Hydrogen, and then 2 oxygen. Now that is the smallest fraction of element that can exist there. Now times a common factor will give us the actual numbers that are there. Now the total weight for the compound is 74. The total weight or mass for the compound is 74. Okay, so when you do that, you just do that simple addition. Okay, so by adding the mass, so let's find the mass, the molecular mass. Let's find the empirical mass. Good. How do we find it? How many carbons are there? We have 3 carbons here. So we have 3 carbons. Each carbon is carrying 12. Okay, and then we have what? How many hydrogens are there? 6. Each hydrogen is having a mass of 1. And then we have how many oxygen are there? Is 2. Each one is carrying a mass of what? 16. The question will give it to you. And then when you add all these masses, we are supposed to get the 74. Okay, you are supposed to get the 74. Remember that this one is the bigger bracket with a common factor. When you do all your addition, you are going to get the inside one to be equal to 74 exactly. You will be equal to, you will get what you call 74. Okay, you get what you call 74 exactly. So the 74, then there's n outside, so multiply here times n over what? 74. So dividing here by 74, dividing here by 74, you are going to get n is equal to what? 1. So it means that the empirical formula and the molecular formula is linked by 1, by a common factor of 1. That means that the empirical, in this case, the empirical formula is the same as the molecular formula, because when you repeat this one and you remove this place, okay, so let's say you remove this place and multiply here times 1. If here is 1, okay, and you want to do that, if here is 1, okay, so if here is 1, then it means that 1 times 3 is the same, and then this time this is the same, that time that is the same. So that becomes automatically equal to the molecular formula. Okay, that becomes automatically equal to the molecular formula. So basically that is what we have. So this is how to determine the molecular formula of a compound. Okay, so in our next lecture we will still continue. This time we are going to find the number of unsaturated double bonds and the number of unsaturated triple bonds, okay, within a particular compound. It is very important for us to know that. Okay, so just follow me. Let's continue this lecture. Thank you.